Magnetic resonance imaging, or MRI, produces high-quality images of the body without using ionizing radiation. Nevertheless, the radio frequency used does require some safety precautions. Although modern scanners are designed to provide a high degree of safety, potential hazards still exist. This video starts with a brief introduction to RF and an explanation of the RF radiation effect. Next, the prevention of unwanted antennas is discussed. Then, the various types of RF effects are mentioned, together with the conditions under which they can occur. The video concludes with a summary and a list of the appropriate safety precautions. RF introduction. To be able to image protons in a large volume, it is important for the applied RF energy to be homogeneous over the whole region of interest. For this reason, a large RF transmit and receive coil, the RF body coil, is built into the scanner. The region of interest is placed in the center of the RF body coil. The closer an RF coil is to the patient, the stronger the detected signal will be. For this reason, small RF receive coils can be positioned close to the region of interest for detailed studies. Some examples are head coils, knee-foot coils, and multipurpose flexible coils. RF radiation effect. The transfer of energy to living tissue has a warming effect, similar to that created by a microwave oven, but much weaker. The patient may experience a feeling of warmth, but there are generally no side effects. Precautions are needed to avoid the occurrence of RF burns, such as local skin reddening or blisters. Unfortunately, apart from the receive coils, resonant induction loops can be created accidentally. These may act as additional unwanted RF antennas. Electronic RF filtering is applied to prevent cables and other components of RF receive coils becoming part of potential unwanted antennas. Unwanted antenna prevention. Cables should be positioned parallel to the main axis of the patient's support. Loops must be avoided, and cables must not cross each other or other electrically conductive objects. There should be a layer of insulation between the patient and the coils. Philips systems are designed to ensure the optimum separation distance, but under some conditions, for example if the patient's arms are within the scanner, extra padding may be needed. An unwanted antenna effect can also be caused by the interaction between cables or coils and the patient's body, or even between adjacent skin surfaces, particularly if the patient is sweating, as this increases the skin conductivity. Types of RF effects. International standards set limits to the level of applied RF energy, expressed as the specific absorption rate, or SAR. However, RF energy absorbed in unwanted antennas can lead to local SAR values exceeding these safety limits. This can lead to RF burns in several different ways. A cable or component in contact with the patient's skin can heat up and cause a burn. Currents running below the skin can cause internal burns. In this case, the component is not heated. In the case of skin-to-skin contact, the surface area is small so that high energy discharges can occur. Conditions. The likelihood of an incident increases with the RF energy level. Since high-field systems operate at higher RF energy levels, particular attention must be paid when using high-field systems. Over the course of time, RF coils are subject to wear and tear. Never use damaged RF coils. There is a growing tendency to scan with SAR levels approaching the maximum of 4 watts per kilogram for a whole-body scan. This can warm up the patient, resulting in increased perspiration. It is advisable to minimize the use of scans with high SAR levels. Shorter image reconstruction times result in shorter intervals between the scans, so the patient has less chance to cool down. It is therefore advisable to spread the high SAR scans across the entire exam by interleaving them with lower SAR scans. Summary. Although MRI is a safe diagnostic modality, there are still some potential hazards, including the possibility of RF burns. Modern scanners have built-in safety features that are designed to prevent this problem. However, as more and more electronic devices are added to the patient, careful positioning becomes increasingly important. Some safety precautions should always be observed. Remember that RF coils may heat up during scanning. Minimize the use of high or default SAR mode. Schedule patient cool-down breaks between high SAR scans. Prevent skin-to-skin contacts, creating current loops. Keep sufficient distance between RF coil cables and the patient's skin. Keep RF coil cables straight, avoid loops. Keep RF coil cables parallel to the main magnetic field. Keep RF coil cables and ECG/VCG cables separated. When combining RF coils, pay special attention to cable handling. Never use damaged coils. This video highlights some of the basic guidelines for safe operation of an MR system. In addition to this, you should read and understand the chapter on safety in the instructions for use of the MR system. If issues are not clear, please contact your local physicist or applications specialist. Provided that the appropriate safety precautions are observed, MRI is an inherently safe modality, producing images of outstanding clinical value.